Part dos.
Yes, piecewise graphs. So you've seen these in Algebra 2. They may or may not have clicked fully, and so here's your chance to actually understand them for real, for real.
They're going to come back next year, so for real is important.
Yes.
Now, this could be a situation where it's possible you don't understand everything we're saying, but you need to follow the steps that we show you today, and understanding will click in later, I promise.
Yeah.
Wouldn't you agree?
I agree. So a piecewise defined function is a function that is made up of more than one function. Little typo there, more than one function. These functions...
Obviously, Mrs. Stevenson did
Obviously
these notes.
I did, because otherwise they look perfect.
Yes.
Okay, these functions are restricted to a certain part of the domain of the overall function. So here is an example on your paper of a piecewise defined function. So we've got a function x, but that function we're only going to use when x is greater than or equal to 0.
Right, so...
Not negative?
Not negative. Negative numbers do not apply.
Right. And then negative x if x is less than 0. Now you can, maybe, if you're savvy, just go straight into drawing this. We're going to use a table of values
Let's
here.
do it. Let's change up colors, too, for less than zeros and greater than zeros.
Okay. Less than 0 is going to be grape. So when I plug negative 5 in, which of these two things does that apply to?
The bottom one.
The bottom one. I actually almost just screwed that up.
You
because
did.
I wasn't paying attention.
You were leaning
This
towards the
is-
top. I
yeah,
could see that.
This is the bottom one, and negative 5 is less than 0. So we'd plug it in right here and
so
say,
negative 5.
which is
Positive 5. Yep.
And that should happen all the way down here.
So negative 4, positive 4.
Uh-huh.
Negative 3, positive 3.
Uh-huh.
Negative 2, positive 2.
Uh-huh.
And negative 1, positive 1. Oh,
Yeah.
but we okay now.
Now, here's the deal. Where it switches needs to be plugged into both functions.
What?
I know. Here, when we plug in 0, we get 0. And what happens is that this is going to have an open dot on our graph.
That's right, because we can't actually include the 0 at this point. But we can get, the whole annoying game you play with your brother or sister.
Yeah, I think we talked about it last video, right?
Really
I'm not touching you. I'm not touching
close.
you. You got really close there. Okay, so that's why we need the open dot, because that will help us on our graph see like negative 0.1.
Right.
Because that is still less than 0.
Still less than 0. So is negative 0.0001.
0001. Beat ya. Okay, so let's go ahead and graph this.
0.00001.
Okay, so got this little
Those are
situation
excellent.
going.
Yep. Keep going. Good hands. Open circle. Open. Oh.
It's okay. Calm down. It's okay. And
I want to draw a straight line.
Okay, you ready for this?
Yeah. Cheating. That's
There we go.
cheating.
You didn't say I couldn't. Okay, now let's switch to the other function. Let's make this be moss, which is green.
Sounds perfect. So now, but look here.
Yeah.
This is greater
0
than
through 5.
or equal to 0, which
Right.
means that we can actually use this point. So whatever we
Right.
plug in for 0 now, that's closed.
Yes, that's closed. That's not an E there.
Is that
Closed.
elost?
Okay, so plug in 0 to x and you get 0. Plug
Right.
in 1, you get 1. 2, you get 2. 3, you get 3. 4, you get 4. 5, you get 5.
Right.
So
I like all of that so far.
now 0, 0 before was open, we're going to fill it in. And sometimes that'll happen that you'll do the first part and be like, oh, that's an open circle, but then the other function
Fills in the
actually
circle.
fills it in. So draw the rest of that.
And
for us.
sometimes it won't happen that way, and you'll have an open circle and then a closed filled-in circle in another place. So we're going to just put these points in here. 1, 1,
And quit, and then go
2,
second,
2.
x negative 1, and go down to
All right, and then so we cap this guy off with a line, and so this actual piecewise function creates a situation that looks like absolute value, perhaps.
And that's it. Actually, did you already say it asks us that? Which of the 12 basic functions is it the same as?
Son of a gun! I've got to
This is-
start reading these things.
I know, right? This is the same as just if we had written one function, y equals the absolute value of x. Rarely does that happen, though.
No, not very often.
Normally, our piecewise graphs look crazy.
Yeah, like
Like you wouldn't believe.
Yeah, I agree.
Okay. But that's it for this one. Are we
Okay,
done?
yeah.
We're done.
Good talk. Example 2,
Let's do another one.
brought to you by
Chipotle.
Chipotle.
Code word today is going to be,
Chipotle.
or some people pronounce it Chipotle. Chipotle, you
Just
know.
make sure you spell it right. Chipotle.
I bet your iPhone will correct, or whatever phone you have will correct it if necessary.
Okay.
All right, now
I
we've got...
created myself a Diet Coke with lemon.
Nice. We've got 3 functions here. We've got 3 tables. If you look, our first table is talking about numbers less than -2. Our middle is talking about between -2 and 1. And our last is talking about 1 and greater. And each time we do plug in the switching point twice. Okay? The -2 and the 1 get plugged in twice.
But you can only include it when it's equal to.
Right. So if x is less than -2,
Thank you.
if x is less than -2, that's this first one. So plug in -5 and you get -4. Plug in -4 and you get
-3.
Plug in -3.
-1.
-2. -2, you plug in and you get -1. Now you also could sit here and say, I know what the line y equals x plus 1 looks like.
Right.
It has a y-intercept at 1 and a slope of up 1 over 1. But the thing is you don't want to draw it anywhere to the right of -2. You want to like follow it back here and then draw your line.
Right. And it's going to keep going because those are all the values. Even though we run out of graph space,
Yeah.
this line continues to fall down and to the left.
Okay, so when we
We had to take a small break.
yeah, so we've got that first line drawn. Now the middle goes with the middle here, so we're going
Right.
to plug in these values. And these are both equal to,
So,
these will
so
both
we're
be
going to
closed
fill in,
dots. All of those are closed dots.
fill them in, fill them in.
What are you trying to say?
Nothing,
'Kay.
obviously.
So plug in -2. Now that requires a little bit of work. Make sure when you plug in negatives that you do the parentheses situation.
Okay, listen to me. You, listen to me. It is not -2 squared on your
Making
calculator.
it positive.
Yes.
No.
Don't do that. It is negative parentheses -2 squared. Exactly. You type it in exactly how Mrs. Stevenson wrote it, and or you will.
It'll tell you the wrong
A
answer.
puppy will die.
You keep saying that. That makes me so sad. Okay, and then plug in -1, same way. And we get 2. And plug in 0.
-0 though. Seriously.
Well, 0 squared is 0. You make it negative, and it's still 0. 0 is neither negative nor positive.
What?
I know, right? Isn't that crazy?
Mind blown.
And then plug in 1.
Now you type it in exactly how it looks here. This is not a parentheses situation.
You could put parentheses around it, but if you
But
did,
only
you'd put
around
it
the
right
1.
there.
Yeah.
1 squared is 1. That makes it negative. -1 plus 3 is 2. And then again, depending on your knowledge of what parabolas look like, you could maybe draw this without actually having to
Right.
do this big long table. We've got 0, 3 is our vertex, and it's opening down. So it's this situation. Just make sure you stop drawing where you need to.
Right.
And then, what is it? -2. Oh, it fills that one in. That's
Nice cookies.
cool.
Oh, you're not done yet. You're not done.
Oh. Okay.
All right.
Okay, that's pretty good.
That's a really
All right,
good.
last function.
That's really good.
Orange. Tangerine.
Tangerine
All right, plug in
colors.
1, and you get 1 minus 1 is 0. Square root of 0 is 0.
Oh.
Negative is
Oh, what did you
0.
say that the square root of 0 was?
0.
Really?
Yeah, because
you can
0
take the
times
square root of 0.
is 0. Yeah, you can.
Are you sure?
For real.
Because some of you are going to try and say you can't do that.
And that will make him angry.
A puppy might die.
If I plug in 2.
Brought to you by Chipotle.
Probably don't want to put those together. 2 minus 1 is 1. Square root of 1 is 1. The negative on the outside makes it a -1. Now, here's the deal. 3 is going to be some sort of decimal.
Yeah, it's going to be really, really weird.
4
you could write negative square root of
is
2
going
if you
to be
wanted to.
decimal. Yeah, that's true. We could. We could, couldn't we? That would be negative square root of 2.
Yeah,
Right.
go ahead and write that, and that's
Negative square
okay.
root of 2. And this
And
would be
then-
negative square root of 3.
Right.
And this would be negative square root of 4, but
square
we
root of
know
4?
what that is,
Peace out, home slice.
which means negative 2.
2.
So, but you can skip these when you're graphing, or you can approximate them. It's whatever.
So 1, 0. Open circle. Open. Open.
That was a close
Oh
one.
man, you almost messed up.
If since the pink one was a closed dot here, it has to be an open dot.
Yeah, you can't. Yeah,
Because otherwise this wouldn't pass the vertical line test.
that's correct.
So then 2, -1, and then I'm going to skip over to 5, -2.
Right.
And connect these dots.
And when you connect those dots, you're going to roll through -√2 and -√3. So
Yeah,
that's why you
yeah.
don't necessarily need to find those.
Absolutely. Now, this is our piecewise function. This is the weirdness we were talking about
Right.
in the last example that happens. Now, the second question on this was, what could you do to make this a continuous function?
Well, I have an idea.
Okay.
What if we took that tangerine-colored graph and raised it up 2 units?
Okay, so you're saying, actually, let me switch that. You're saying we take this point and move it to here.
Yes.
And that would move this one here.
Right.
And that would move this one here.
Right.
And then, so does that look like it's continuous?
Yeah, I think so.
'Cause you could trace that without picking up your
That's
pencil.
correct.
So the answer to the second question there is that we could shift negative square root of x minus 1 up to
2 units.
which a little bit later on we'll talk about what that actually
Oh,
does
we're
to
going to
this
talk about
equation.
that so much this year.
Yeah, it's awesome.